Hey guys, we're taking notes today over graphs of sine and cosine functions, and I've drawn an example of a sine or cosine function right here on our notes. I kind of wanted to talk through it as I explained this part in the box. The definition of a periodic function is a function f is periodic if there exists a positive real number c such that f of t plus c equals f of t. So what that means is, like, if you had a point right here, t, you have this y value, which would be our f of t. If you have another point over here, say this right here is t plus c, you have this point right here, which is f of t plus c, and they're the exact same y value, so they're equal to each other. So that's what a periodic graph is. It's basically a wave where you end up with, over the wave, you have multiple places where you end up with the same y values. Okay, the smallest number c for which f is periodic is called the period of f. So basically, from this point to this point, this would represent a period because it takes you that long to start repeating those y values again. So the period is how long it takes on the x-axis for the function to go through one cycle. After one period is completed, the cycle will start over. So we've just covered the unit circle. If you remember our unit circle, we had a circle, and it took us, when we did our unit circle, it took us a full lap around that circle, so 2 pi, for us to actually get through the circle and all the possible values on the unit circle. So that's why the period of the sine and cosine function is going to be 2 pi. So look at the following statements about sine and cosine functions. We've got sine of t plus 2 pi n. This just allows you to get those coterminal angles. Every 2 pi units, we should have a coterminal angle that has the same value. And the n is just doing it over and over and over again. So sine of t plus 2 pi n equals the sine of t, and cosine of t plus 2 pi n equals cosine of t for any integer n and real number t. So what makes the above statement true? It takes you two pi radians to go around the circle. And you have a coterminal angles every 2 pi radians. So let's look at a graph of that. Okay, so we're going to look at the graph of y equals sine x. You guys have really studied hard your unit circle, and you know how to find the sine of any angle within that unit circle. These right here represent our quadrantals. That's the ordered pair 1, 0. That's the ordered pair 0, 1, negative 1, 0, and 0, negative 1. Those are the values for cosine and sine on our quadrantals. So if we're focusing on the sine, we're focusing on the y values for each of those ordered pairs. So at 0, whenever, if our theta is 0, our sine of theta would be 0. Our sine of, remember, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. So at pi over 2, our sine of pi over 2 would be 1. At pi, our sine value is 0. At 2 pi, 3 pi over 2, our sine value is negative 1, and at 2 pi, our sine value is 0. Honestly, those are the ones I mainly focus on. You can get all of these baby ones in between, and it might be easy to help you kind of visualize what the graph looks like a little better. We learned that the sine of pi over 6 is, hello. Sorry, I got interrupted there for a second. We learned that the sine of pi over 6 is 1/2. We learned that the sine of pi over 4 is square root of 2 over 2. Pi over 3 is square root of 3 over 2. If y'all just remember your unit circle, 2 pi over 3 is square root of 3 over 2. I can't write this small, sorry. 3 pi over 4 is square root of 2 over 2. 5 pi over 6 is 1/2. Remember, between here and here, this is all quadrant, this is quadrant 1, this part is quadrant 2, and the sign is positive in all those values. So all of those numbers should be positive. And then starting down in the third and fourth quadrant, you should see some negatives. All right, so you can get even more baby numbers like that if you want, but again, the main ones I focus on are at 0, 0, I have a point. At pi over 2, it should be up at 1. At pi, you're back at 0 again. At 3 pi over 2, you're down at -1. At 2 pi, you're at 0. And that represents 1 full period. If you had done the negative angles, gone the opposite way, at negative pi over 2, that would have been this location right here. So the y value would have been a -1. At negative pi, it would be 0. At negative 3 pi over 2, it would be +1, and at negative 2 pi, it would be at 0 again. So you can see the sine wave. One thing to think about as far as the key characteristics is that it goes through the origin. It has a point at 0, 0. The domain is all real numbers. It goes on forever. So you can either say all real numbers, or you can say from -infinity to infinity. The range value, this is pretty important for us to notice. The range, it doesn't go any higher than 1, and it doesn't go any lower than -1. So our range goes from -1 to 1. All right, another key characteristic that we need to notice on our graph, let me erase some of this. So it's, oh goodness, I erased the whole thing. Let me redraw it, sorry. Okay, another key characteristic that we need to talk about is to list intervals where the graph is increasing. So remember what it means to be increasing. It's the x values where the y values are getting bigger. So as you read it from left to right, where are the y's rising? So if I look on my graph right here, let me see if I can change that color. So if you look from here to here, this is where the y values are increasing. At every maximum or minimum, it changes from increasing to decreasing. This is another place that it's increasing. This is another place that it's increasing. So if I'm just looking at the graph that I have graphed, remember this goes on forever, so there's a lot of different places that this is going to happen. But if I list 2 intervals on this particular graph where it's increasing, I'm actually going to list the 3 that I have highlighted. It's increasing from -2 pi to -3 pi over 2. It's also increasing from -pi over 2 to pi over 2. It's also increasing from 3 pi over 2 to 2 pi. That's just using the graph that I have graphed right there. I didn't graph the full function. Intervals where it's decreasing, I'm going to change my highlighter to something else. How about yellow? So where it's decreasing is from here to here. As I read it from left to right, the y's are going down, and again, each of those maximum and minimums are going to be where it changes. Right here, it's also decreasing. So if I'm going to write intervals where the graph is decreasing, it's going to be from -3 pi over 2 to -pi over 2, and then also from pi over 2 to 3 pi over 2. Now I usually use parentheses because at this point right here, at the -3 pi over 2, it's leveled off. It's not increasing or decreasing right there, so we should just use parentheses at those locations. All right, so that's the graph of sine. Let's move on to the graph of cosine. Okay, looking at the graph of cosine, remember when we have our ordered pair, x, y, on our unit circle, the x values are our cosine and the y values are our sine. So I've drawn the unit circle over here. I always draw that just because I'm probably a nerd and I just want to make sure I'm doing it right every time, but might be a good idea for those who are struggle with it a little bit. So when theta is 0, the cosine of theta is going to be 1. At pi over 2, the cosine will be 0. Just looking again at these x values right here. At pi, my x value is -1. And at 3 pi over 2, my x value is 0. And at 2 pi, it's 1 again. So again, those are the important ones. And if you remember your unit circle, you could think of even these little angles in between right here. So at pi over 6, it's square root of 3 over 2. At pi over 4, it's square root of 2 over 2. At pi over 3, it's 1/2. At 2 pi over 3, it's a -1/2. Remember, all of these right here, 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 all of these right here are in quadrant 1, so they should be positive. Starting right here, we're in quadrant 2, and cosine is negative in that quadrant. At 3 pi over 2, it's at 3 pi over 4, it's negative square root of 2 over 2, and at 5 pi over 6, it's negative square root of 3 over 2, and then we have the others. Okay, I'm going to plot the main one. So at 0, it should be right here at 0, 1. I accidentally made that mark right there, sorry. So at 0, 1, we have a point. At pi over 2, we're at 0. At pi, we're at negative 1. At 3 pi over 2, we're at 0. And at 2 pi, we're back to 1 again. So this represents a full period. It's one loop around that circle, the unit circle. If you think of your negative angles, you're going in the clockwise direction. So negative pi over 2 is going to be 0. Negative pi would be negative 1. Negative 3 pi over 2 is going to be back to 0. And negative 2 pi is going to be back to 1 again. So this is 2 periods of this function. So remember, one period would be from here to here. A second period would be from here to here. It's basically from tip to tip. This represents 1 period. That's supposed to be an E, sorry. This represents a second period. So our period, remember, is 2 pi units. All right, thinking about your domain and range, this actually goes forever. So we would, if we were to finish it, it would go right here, and it would go right here, and it would go on. We limited it at some point. So again, my domain is all real numbers, and we go from negative infinity to infinity. My range, again, this is pretty important. It doesn't go any lower than negative 1, and it doesn't go any higher than positive 1. All right, 1 period of the sine and cosine function is 2 pi. That's before any transformations, which we will do here soon. But when you start doing transformations, you change that period. Otherwise, if it's the parent function, it's going to be 2 pi. If we want to talk about intervals of increase and decrease, so where it's increasing, an example of an interval where that happens would be from, let's say, from right here to right here. That's an example interval. So I could say from pi to 2 pi. An example of where it's decreasing. Let's see, change that color. So where it's decreasing would be, I did not draw that very well, did I? Right here, this should have leveled off right here. How did I do that? Should look more like that. I'm sorry about that. Okay, so the places where it's decreasing from, for example, right here to right here. So that would go from negative 2 pi to negative pi. All right, so that's the cosine graph. You know what? I'm going to draw that a little bit better because I think that looks terrible, and that's going to bother me. So right here at 0, we're at 1. At here, we're at 0 and 0. Negative 1. Oh, sorry. So let's see if I can do this a little better. Sorry about that. All right, so this is what your cosine graph should look like. Another key characteristic I want you to think about, the sine graph, it went through the origin. The cosine graph does not. It has its highest point. When x is 0, it'll be at 1. Just one way to help you distinguish between the two. All right, let's do another one. Okay, let's talk about another key characteristic of the sine and cosine curves. Each of them have what we call an amplitude. And so you can change that amplitude when you do a transformation with this a value right here. So the amplitude of the equation y equals a sine x and y equals a cosine x represents half the distance between the maximum and the minimum values. So for example, if you had a graph, I'm kind of draw what looks like a sine wave. This part right here, that's going to represent my amplitude right there. So this is my max. This right here is my minimum. And so halfway between them is this A that I've drawn right here. That's going to be your amplitude. So our amplitude is always given by the absolute value of A, so the amplitude will always be a positive value. The function will range between negative A and A instead of -1 and 1 if you've made that transformation. So if you've changed the parent function and you made it something like y equals 5 sine x, this would tell me my amplitude is equal to 5 because of this number right here. Okay, so that, now we're going to talk about some other transformations. Translations, remember that's where you slide left or right or up or down of the sine and cosine graph. So you've learned all of these before whenever we did Algebra 2, and we've done some in pre-cal as well. The A represents our amplitude. This B value right here, that's going to affect our period. And how we get our period is we do 2 pi divided by that B value. You know, 2 pi is our original period. So if it changes, remembering those transformations, that value that's with x, you do the opposite of it. So basically what you're doing is 2 pi times 1 over b, which gives you that 2 pi over b value. And then a phase shift, so this is whenever you go left or right. We call it a phase shift when we're doing sine and cosine. That's from the C value. The D value is a vertical shift, so that's when you go up or down. So very similar to what you've done with every other transformation for other functions. All right, let's do some examples. Okay, before we do an example, I should probably talk about this horizontal shrinking and stretching. Do you remember y equals f of x? If y equals f of x, what occurs when we have f equals f of 3x? So basically what we've done right here, that's our b value that's changed. That's a horizontal either stretch or a compression. So if you have a sine wave or a cosine wave, either way, basically what you've done is you've either tightened it up, so it's just going to be a tighter wave, or you have spread it out depending on what that b value is. So that's what the number in front of the x will do. The horizontal shrinks and stretches will always affect the period of the function. For functions y equals a times sine b of x, this b value right here on either one of those is what we're going to plug in to get what the period is. All right, now let's do some examples. Okay, for this first example, we're taking the cosine graph and we are vertically stretching it by 3. I'm going to write that here. That's a vertical stretch by 3. And so that's going to affect the amplitude. So my amplitude will now be 3. Before it was 1. Your period has not changed. We don't have a b value that's right here in front of the x. So my period will still be 2 pi. My domain has not changed. It's still all real numbers, so it'll be -infinity to infinity. This amplitude, that's going to change your range. It's going to be from -3 to 3. Remember on the parent function, it was -1 to 1. So you've now changed that because you changed the amplitude to be -3 to 3. And so when we talk about our transformations, we have a vertical stretch by 3, which is an amplitude change. All right, so I've kind of drawn the unit circle information over here for our quadrantals, and I'm going to use those numbers when I think about what I'm going to plot. I'm going to do the table just to kind of help guide you. So at 0, when x is 0, my y value would be, oh, I'm sorry, we're talking about cosine. So my x value is going to be what I'm going to put here for y, which would be 1. At pi over 2, my x value, which is the cosine, is 0. At pi, my x value, which is the cosine, is -1. At 3 pi over 2, the x value, which is the cosine, is 0. And then at 2 pi, I'm back to 1 again. So the transformation that we're doing is going to change the y values. We're going to stretch those y values by 3. So I'm going to multiply all my y's by 3. So this becomes 3, 0, -3, 0, 3. So I will be plotting these y's with these x's. Okay, so at 0, we're up here at 3. At pi over 2, we're at 0. At pi, we're at -3. At 3 pi over 2, we're at 0. And at 2 pi, we're up here at 3. and then going back around. Okay, so my graph should look something like this. Okay, so in looking at that, this right here, that tells me my amplitude, and my amplitude equals 3. And again, this part from that tip to this tip, that represents the period. And I went from 0 to 2 pi, so that shows me my period was 2 pi. So just some things to look at on the graph. All right, let's do another example. Okay, on this example, I've kind of already started it. We're going to do the cosine again. So on our unit circle, we're focusing on the x values. And we're changing it by this 5 right here. That's a vertical stretch. Hold on one second. Okay, I just realized that I skipped number 2. So I'm going to go ahead and finish number 3. I'm sorry, and we'll go back to number 2. Sorry to confuse things. I hope I haven't terribly. Okay, so on this problem, though, we are vertically stretching it, so our amplitude is changing by 5. Sorry, it's a vertical stretch by 5, which is an amplitude change. I'm also changing it by doing a translation. I've moved to the left pi over 4 units. So we would call that a phase shift when we go left or right. So we did a phase shift left, pi over 4 units. All right, so the 5 is going to change your y values. I'm going to multiply all my y's by 5, so that'll be 5, 0, negative 5, 0, and 5. My x's are going to go to the left, pi over 4 units. So you're going to be subtracting pi over 4 from each of these. So this will become negative pi over 4. You might need to get a common denominator. So pi over 2 is 2 pi over 4. And when you subtract pi over 4 from that, you get pi over 4. Pi minus pi over 4 is 3 pi over 4. 3 pi over 2 is the same thing as 6 pi over 4. So when you subtract pi over 4, you get 5 pi over 4. And then this would be 7 pi over 4. All right, so let's see if I can graph this. I'm going to pause it and kind of plot my points so you don't have to watch me scramble through that. Okay, if you notice, each pi over 4 is about halfway between every pi over 2 units, and so I've kind of got dots there to mark that. So we'll have another one right about here. That'll be where this comes back down again. And then you'll have another one about right here, so that should be where it's down at negative 5. You usually want to do about, you want to do 2 periods, and so that should help you kind of see how far you want to graph each of these. So I've now graphed 2 periods. I know that I have because if you'll notice from this tip to this tip, that represents 1 period, and then here would be another period. All right, so again, each period is 2 pi units. If you subtract that 7 pi over 4 minus this negative pi over 4, that ends up giving us 2 pi units. I can show that. 7 pi over 4 minus the negative pi over 4. Would be 8 pi over 4, which is just 2 pi. So that represents my period. Also notice that this represents my amplitude, which is 5. So over here, in answering these questions, my amplitude is 5, my period is 2 pi, my domain is all real numbers, and my range goes from negative 5 to 5. All right, let's go back to number 2 since I accidentally skipped that. Okay, on this next one, we're finally doing a sine graph, and I've drawn my unit circle for the quadrantals, and I've made a table for each of those values. Notice right here, this 4 tells me I've changed my amplitude, and this is technically going to also change my range because it's a shift up or down. So my transformations are a vertical stretch by 4, which means that's an amplitude change. And then I've also got a vertical shift down 2. Okay, so your amplitude is now going to be 4. We didn't have a b value with that x, and so our period has not changed. It's still 2 pi, which means my domain is always going to be all real numbers for these functions. My range has changed because my amplitude and that vertical shift, and I'm going to wait to say what the range is until after we do the actual graph. Okay, so changes on the table. All right, the y's have been multiplied by 4, and they have shifted down 2. Actually, I didn't need anything in the x column because we didn't change anything for x. Sorry about that. So I'm going to take each of these y's, multiply them by 4, and go down 2. So this becomes negative 2. 4 minus 2 is 2. 0 minus 2 is a negative 2. Negative 4 minus 2 is a negative 6, and then 0 minus 2 is a negative 2. Okay, I'm going to plot those points, and so I'm going to pause it real quick, and then we'll look at it. Okay, looking at the points that I've plotted from the table, you can finish the graph. You can see that your low point is down here, and so I'm going to finish this by drawing down here, and then this is at every pi or pi over 2. Another thing I want you to think about is this is kind of your, let me change the color of this pen real quick. This is kind of your, where your x-axis has moved. It all shifted down 2 units, so it kind of helps you visualize that a little bit better. Okay, so I'm going to finish that graph. Okay, looking at this graph, again, this dashed line right here represents our midline, the halfway point. So our amplitude goes from our highest point to that halfway point, or from our lowest point to that halfway point. So you can see your amplitude is 1, 2, 3, 4 units. So that's why we have an amplitude of 4. My period goes from here to here, tip to tip, and that's another 2 pi units. But my range has changed because of shifting down and because we changed the amplitude. So my lowest y value is negative 6, and my highest y value is a positive 2. So remember, you took your original range, which is negative 1, 1, you multiplied them by 4, and then you shifted them down 2, so that could help you get this as well. All right, hang on 1 second, we'll do example 4. Okay, for example 4, we have an amplitude change with this 3 right here. The negative, though, is going to reflect it. So your amplitude is actually always positive, so it's just going to be positive 3. So your transformations so far are an amplitude change. You had a vertical shift by 3, which again changed the amplitude. You also reflect it over the x-axis. That's because of that negative. And then you also are going to have a period change. It's going to be a horizontal compression, if you'll recall that. Okay, so your period, remember we get by doing, I'm going to change this pen color. You get by doing 2 pi divided by your b value. This 2 right here, that's your b value. So you're going to be doing 2 pi divided by 2, which just equals pi. And so your period this time is just pi. Your domain will always be all real numbers, so it's going to be negative infinity to infinity. Your range, which was from negative 1 to 1 on the original. So you're going to be multiplying those y's by negative 3. So that'll make it go from negative 3 to positive 3. And we'll see that when we do our table over here. So I'm going to pause it for a second and do my table. Okay, I've set up my table using all of those quadrantals and what the cosine is at each of those angle values. So for the y's, because of that negative 3 in front, we're going to multiply all of our y's by negative 3. So this becomes negative 3, 0, 3, 0, and negative 3. On my x's, remember anytime it's with x, it's opposite of what you think. So you'll multiply each of your x's by 1/2 because of that 2, that's the b value. So this becomes 0. This is going to become pi over 4. This will be pi over 2. This will be 3 pi over 4, and this will be just pi. So I'm going to plot these x's with these y's. All right, so I'm going to plot some of those. Okay, this is what our graph should look like after we plot a few of those. Let's just talk about some of our critical values. Like, for example, my period goes from here to here, tip to tip, and we should see that that's only pi units, which matches what we put over here for the period. My amplitude, this is my halfway line. So my amplitude is from that halfway line to the highest point or from the halfway line to the lowest point. And that's 3 units, so that matches my amplitude right here. My range goes from -3 up here to +3. And that's our graph. All right, let's do another example. Okay, on this next one, we have a reflection across the x-axis again. We also have an amplitude change, so it's a vertical stretch by 4, so that changes the amplitude. We also have a period change, which is a horizontal. Either, in this case, it'll be a horizontal stretch by 2. So my amplitude is going to come from this 4. Remember, the amplitude is always positive. My period will change by this. It's understood this right here is the same thing as saying 1/2 x. So my b value is 1/2. So I'm going to be doing 2 pi divided by 1/2. Remember, you do 2 pi divided by b to get the period. All right, so 2 pi divided by 1/2 is the same thing as saying 2 pi divided by 1/2, or 2 pi times 2 over 1. So that will be 4 pi. My domain is all real numbers. My range, it was, from -1 to 1 before. That -4 is going to change that. So it's now going to be -4 to 4. All right, so the changes over here on my table, I'm going to multiply all my y's by -4. I'm going to multiply all my x's by 2x. So this becomes 0, -4, 0, 4, and 0. And this becomes 0 pi, 2 pi, 3 pi, and 4 pi. All right, let's see what this graph looks like. All right, and looking at this graph, your period comes from here to here. You should see that you've got a period of 4 pi before you start repeating yourself. Your amplitude comes from, this is your midline. Your amplitude comes from the highest point to that midline, and it's 4 units. I probably should have been bringing this up each time, but remember, think about where you're increasing and where you're decreasing. On the normal sine function, it looks like this, just a wave that looks like that. And so it's increasing on this interval right here. We've switched that where it's now increasing right here and right here. Instead of this middle part right here, this is decreasing. And that's because of that reflection. So just something to think about. So where we're increasing on the graph that I'm showing below is from -2 pi to pi, or sorry, negative pi, and then union from pi to 2 pi. And where you're decreasing would be from negative pi to pi. That's just on the part of the graph that I have graphed. There's a whole bunch of other places that those increasing and decreasing are happening. I was only able to graph one period on this particular graph based on what we have marked here, but hopefully you can see that it's also been stretched out a little bit because of that period change. All right, let's do another one. Okay, on this one we have a lot of things happening. This 4 right here is going to be a vertical stretch by 4, so it's going to change your amplitude to be 4. This 2 right here, that's going to change your period, so it's going to be a horizontal compression by 2. Again, that's going to change your period. This will change your amplitude. This right here is going to be a phase shift. You're going to go right pi over 2. And then you also have this 3, which is making you go a vertical shift up. by 3. So what that means to you is that this halfway line that's normally the x-axis, it's going to be up here where 3 is. That's your new halfway line. Okay, so your period, remember we get by doing 2 pi divided by b. My b value is 2, so we do 2 pi divided by 2, which gives me a period of pi. My domain is all real numbers for these. My range, which is normally -1 to 1 on the parent function, you're multiplying each of your y's by this 4 value, and then you're adding 3. So if I multiply this -1 by 4 and then add 3 to it, I get a -1. And then if I take this 1, I multiply it by 4 and then add 3 to it, I get 7. So that's your range. I'm going to graph this over here, and so I'll pause it real quick. Okay, so I'm sorry, it seems like my hand must have been shaking when I did this. Again, you have the halfway line. Hopefully you see right here. This represents our amplitude, which is 1, 2, 3, 4 units, like we said over here. If you look from tip to tip, we have from -pi/2 to pi/2. That's a period of pi, so that matches our period right here. Our range goes from this -1 up here to this +7, so that matches our range. And that should be what your graph looks like. All right, let's do number 7. Okay, on this next one, I kind of went ahead and filled in a lot of things. For one thing, what I want you to notice that you have a vertical stretch by 3, so that's going to change your amplitude to be this 3 right here. Your period is a little bit different. That b value, you're going to be doing 2 pi divided by b, so that will be 2 pi divided by pi over 4. So 2 pi divided by pi over 4 is the same thing as 2 pi times 4 over pi. So those pi's cancel, so that means your period is just 8. There is no pi in that this time. You have a horizontal translation. You go to the left 2, that's a phase shift, and then you go down 1 with that right there. So your domain is all real numbers. Your range, which started at -1, 1, has changed by multiplying your y's by 3 and then subtracting 1 from them. So it should become this when we graph it. And I've kind of shown all of that with this table. I did my original x's and y's, and then to each of my x's, I multiply them by, remember if you have this b value of pi over 4, you have to do the opposite of it when you change the x's. So you multiply them by 4 over pi. And then you're going to subtract that 2. Again, all of this should be opposite of what you have when it's with the x. To the y's, you're going to multiply each of your y's by 3 and subtract 1. So now my x values no longer have pi's in them like all of our other graphs did. So we need to go up here and just make this a 1. This is this is 2, 3, 4, 5. This is -1, -2, -3, and so on. And let's graph that. Okay, so this is what our graph looks like. This time I'm going to focus on the tips right here and here. So from -4 to 4, that shows my period. So I have a period of 8. My amplitude right here, it shows that it's 3 units like it should be. So this is our graph. All right, let's do number 8 and 9. Okay, on these, you're looking at the graph and you're trying to write the equation. So you should be looking at things like this. This is from tip to tip, and if you look, you're going from -pi to pi. That's a distance of 2 pi. So that tells me that there's no period change. Yay, no b value. And then if you'll notice, like normally the cosine function, it looks like this, where your highest point is on that y-axis. Well, your lowest point is on the y-axis, so that tells me it reflected. My amplitude from the highest point to that halfway line is 3, so that's an amplitude change. So I'm going to write the equation as y equals a -3. The negative takes care of the reflection, the 3 takes care of the amplitude. I did not have any shifts or period changes, so it's just going to be y equals a -3 cosine x. On this next one, this is my halfway point, so that tells me that I shifted up 2 units. Okay, also I have an amplitude right here of 1, so there is no a value, it's just 1. I guess it is 1. If I go from this tip right here to this tip right here, so from -pi/2 to 3 pi/2. And you can subtract that. 3 pi over 2 minus a negative pi over 2. That gives me 4 pi over 2, which is just 2 pi. So we don't have a period change. Normally your sine graph looks like this, where it goes through the origin, but normally it's increasing from here to here. We have it decreasing on that side of it. So we have reflected it to make it look like this. So this is a reflection. So I need to show that in my equation. I'm going to have y equals a negative sign. That shows the reflection of x. We didn't do any period change, so no b value, but I did shift it up 2, so I need to show that plus 2. Okay, that's all for your notes. Thanks, y'all.